Hi there, Hello College Math students. In this video we're going to introduce compound interest and do a couple of compound interest calculations. So at this point you've studied some simple interest calculations. Now compound interest is slightly different. However, we can do compound interest calculations using the simple interest formula, and I'll demonstrate how that works here and demonstrate the difference between simple interest and compound interest. So Alice deposits $1,000 in an account paying 12% per annum compound interest paid annually for 3 years. Now if we did this simple interest using the simple interest formula, we would have that the amount of interest is equal to the principal, 1,000, times the rate, 0.12 for 12%, times 3 years. And that would give us a grand total of $360. So by the end there'd be $1,360 in the account. Okay, so rather than doing that, I'll just keep that number up here, $1,360. Let's compare this to a situation where the money is compounding year on year. So I'll set this up like this with year 1, year 2, and year 3. So in year 1, if we did this 1 year at a time and compounded it on the way through, we'd have a principal of $1,000, the rate 0.12, and the time, the first year, 1 year. So the amount of interest is 1,000 times 0.12 times 1, which is $120. So this adds to the principal and carries over as the new principal for year 2, $1,120. So that's 1,000 plus the interest for the first year. The rate stays the same. Now this is interesting. T equals, for year 2, T equals 1. I know that we're in year 2, but because we're going 1 year at a time, this is for a period of 1 year. Okay, so we take our new principal, and this gives us $134 worth of interest. Well, $134.40 to be precise. So that adds to the current principal, 1120, and carries over into the next year. So $1254.40. Same interest rate and same time period, 1 year. And we do our final calculation. 1254.40, which gives us $150.53. So when we add that to this principal here, we finish with $1,404.93. So we can see that if the money compounds year on year, it adds up to more than what the simple interest would for the same conditions. So the reason for that is that when this amount of interest at the start for the first year was calculated, that became part of the new principal, and we earned more interest on that interest as well as the original principal. And same for the next year. So we end up earning a bit more money under compound interest calculations than we do under simple interest. Now if we look at the compound interest formula, we've got these different letters. We've got A is the final amount in the account, P is still the principal, just like in simple interest. Now, I represents the interest rate per period as a decimal, so we're not using little r anymore. We're using I, and we don't have T for years. We've got N for number of periods. So let's have a look at using this formula for this situation. So rather than doing 3 separate calculations, I'm going to do this all in one. Our principal, we start off with a principal of $1,000. 1 plus the interest rate is 0.12. Now the N, the number of years, number of periods or number of years here is 3. So if you put that into the calculator correctly, you should get the same as what we got doing it the simple interest way. So make sure you check that. So we can do this compound interest calculation. Instead of doing 3 separate simple interest calculations, we just do one calculation. Now that's a bit of a time saver, but imagine in a situation where something was compounding for, say, 10 years monthly. That would involve 120 separate simple interest calculations. Well, we can do that all in one go with the compound interest formula. So it's a very useful formula. Now, one of the tricky things is adjusting the I and the N value. So I just want you to pause the video and think about how many times per year would an account compound for each of these situations here. And then I'll reveal the answers. Okay, so if it's annually, that's once a year. Half yearly is twice a year. Quarterly is 4. Monthly 12. Fortnightly is 26. Now that's one that can trip people up a bit. A lot of people think, well, it must be 24 because it's twice as much as the number of months. But what we think is, okay, we've got 52 weeks. 2 weeks is a fortnight. So half as many fortnights as weeks. We work it that way. Okay. And finally, daily is 365 times per year. So we need to remember these when we adjust our I value, our interest rate per period, and our N value, the number of periods. So let me show you how that works. Let's say we have an investment at 6% per annum, monthly for 5 years. Okay, so 6%, we convert that to a decimal, 0.06, but we need to adjust the interest rate and divide it by 12. We didn't need to do that for the earlier example because that was annually and we were just dividing by 1 here, so we still end up with the same answer. But because this is monthly and you have 12 months in a year, you've got to divide your interest rate by 12. Same for this one down here, 0.045, 4.5% as a decimal. This is compounding daily for 2.5 years, so we divide by the number of days in a year, 365. Now for the N value, we take the number of years and multiply that by periods per year, 12. So for this account, the N value, the number of periods, is 60. Think about it, 5 years monthly, 12 times a year for 5 years, that's 60 times. Here we've got 2.5 years, 2.5 by 365 times a year. And what does that give us? Bear with me. 912.5 for our N value. Okay, so that's how we adjust I and N. We divide I by the number of periods a year and we times N for the number of periods per year. So we divide for I and times for N. Alright, let's go to an example with some numbers in there and actually do a calculation. Oh, that's not the one I wanted, we just did that. Here we go. So here are these examples that are in the textbook. So $5,000 is invested in an account, earning 9% per annum added quarterly. So remember our equation, A equals P times 1 plus I to the power of N. So we want to find this amount. Our principal is $5,000 times 1 plus, okay, 9% is 0.09, and we divide that by, because this is quarterly, we divide by 4. And then our N value, okay, this is for 8 years, quarterly, so 8 by 4, which gives 32. So we raise this to a power of 32. Okay, you might want to pause the video here and put that into the calculator and see what number you get. Make sure you can get the same number as what I get. Okay, so the number is $10,190.50. Oh, in fact, it's 52 cents, beg your pardon. Okay, so you might want to pause and try the next one, which uses the same maths. Then I'll have a go at it. Okay, so this is what we do. A equals, our principal is $650 times 1 plus, okay, 0.048, compounding monthly. So this time we divide by 12. Okay, and we raise to this power 5 years monthly. 5 by 12, 60. Okay, pop that into the calculator and see if you get the number I get. And that number is $825.92. Now read the question very carefully, because we're not entirely finished here. What you'll see is that it's asking for the total amount of interest. Compound interest calculation, the A value tells us the total in the account. So that's the total in the account. The interest is going to be this final amount minus the principal. So final minus principal, which gives us $825.92, takes $650. And that is $175.92. That's our final answer, in fact. Alright, so go ahead and try the questions in the description for the video.